Okay. Oh, let me just a second here. Okay. Good morning, everyone. Hello, Vittorio. It's Friday, I know. Have sleep. So, thank you for attending that second session of OAUTH work group here. And let's get going. And Hannes is remote here, so go ahead, Roman.
Hi, I just wanted to kind of repeat a little bit of what I said when we met for the first time and to note a little bit kind of more progress. Again, I'm sorry for the late surprise in which we canceled all of the side meetings. I know that the working group is trying to get as much time they can on site. One of the things that the ISG and the IAB do every time an IETF meeting finishes, the meeting finishes at lunchtime, we actually spend the afternoon hot washing and kind of talking through what happened with the meeting, what can we do better, what are the lessons learned, and one of the things I am going to kind of bring up is how do we solve the problem that the team here is faced with is everyone's on site. They want to get as much meeting time as possible. And we're constrained with kind of all the conflicts. And so we'll talk a little bit about how to problem solve that. I don't know if I have an answer, but again, I'm committed to you guys that we're going to find a plan for it.
Thank you, Roman. Appreciate that. Awesome. Okay. So it's taken a long time. So the note will applies here. Hopefully by now you know what the note will is all about. Hopefully you know the tips too. So let's keep going. This is the second session. Work group updates. We've done that, and this is today's agenda. So unfortunately, Dick didn't make it here to Yokohama this time, so I'll be talking about JOT embedded tokens. Peter, I hope Peter is online. Is he online? Are you?
Yes, yeah. I am. Can you hear me?
Hey, Peter. I know it's late for you. Sorry about that. So Peter will be talking about cross-device flow, and he will continue also to talk after that about identity chaining. Aaron will be talking about native apps UX, and then we'll have a joint kind of session or part of that discussion between Aaron and Mike, talking about those two bullets together in one kind of joint presentation. And at the end, we will have Sri. I think Olav is not here, but Sri will be talking about power of attorney at the end. That's our agenda. Any comments, questions, agenda bashing? If not, let's get going. Hannes, will you be driving the slides? Are you able to drive slides remotely?
Checking whether I can do that. I think I then have to load them. Let me load them.
I've loaded those, right?
Yeah, but then I can't advance it if you load it.
Let me stop. Can you share them?
Yeah. Embedded tokens. Okay. Can you see them now?
Yes.
Okay.
Can you move slides? Yeah, perfect. Okay. Okay. As I mentioned, unfortunately, Dick is not here, so I'm going to be presenting on behalf of Dick Giuseppe and myself to talk about JOT embedded tokens. Next slide, please. So the goal of this JOT embedded token is try to bind more tokens from other issuers into one token and show the relationship between these tokens. So we've been discussing this for some time. So I think next slide. So why are we doing this? There are a number of reasons. Audit trail is an obvious one. Real-time display of information and evaluation authorization. These are three reasons that we think that there is a need for such a combination of an embedding of tokens. Next slide, please. So, and we're talking about embedding multiple tokens from different issuers, and there are a number of use cases, and here we are showing two use cases, one for an access token and another one for an ID token. A prime example of an access token that needs to embed one token into another is a stereo diverted call. This is a telephony kind of a use case. A calls B, B redirects the calls to C, and then C wants to know that the original call was actually to B and not to him directly. So that's the way they do that and embed that first token into the second. Another example is a hello kind of a use case that Dick is working on, where the ID token needs different claims from different identity sources. For example, you can get the date of birth from one source and the education credentials from a completely different source. Next slide. So what we've done is kind of define a mechanism to do that, building on the token exchange protocol, and changing a few things there. So in this case, this is the authorization request. We define a grant type, a new grant type. We call it embedded tokens. And we defined a new claim, tokens, which contains a list of tokens. Inside that list, we'll have a type which talks about the token and the token itself. So that's the request. Next slide, please. And now the response could be either by value or by reference. So in this case, the token is embedded directly by value. So you get a reply with tokens claim, and inside that you'll have a type of the token that is being embedded and the token itself. Next slide. And this is by a reference. So again, similar to the previous one, you get tokens, a claim which has a list of tokens. And in this case, we're talking about a specific type calling it access token reference. And it has a digest, which includes the algorithm being used and the hash of that token and the GTI of that token. Next slide. So that's all we have from talking about the mechanic of that protocol and what we are trying to achieve that. And we've been kind of talking about this for some time, and we feel that it's time for us to kind of adopt this document. We know that a number of work and different areas kind of referencing this document, the W3C verifiable credentials data model reference this document. The mini work at the IETF also references this document. The Italian government has a project that needs a mechanism like this. And Peter will be talking about identity chaining later on, which again builds on this mechanism. So that's all I have. Love to take comments, questions at all.
So just a quick question. What is an example where there are more than one tokens in the array? Like, is it, if a token is embedded into an embedded token, you would assume that it would appear inside the previous token, right? So when would there be a situation where there would be more than one tokens in the array?
For the use cases I am aware of, typically there is one token, but we did not want to rule out like multiple tokens. I think if I remember correctly, Giuseppe has one case that would need something like this, but we just did not want to rule out a use case like this, right? Vittorio.
Hi, Vittorio, Okta. Token exchange is one of the most misunderstood specs we ever produced. And I'm very concerned that here we are doubling down on possible confusion. Like, for example, all this embedding entails that the last point in the chain is able to actually understand and interpret the tokens in the middle, which is non-trivial. Like as we tried in our concrete implementations of token exchange, that is a challenge. The other part is that in terms of claims from different sources, as far as I know, the OpenID Foundation has this claim aggregation spec, which I've been hammering on for a while, and that is also referenced by the verifiable credentials. So it would be interesting to see how those two things play together.
Can you send me a link to that, Vittorio?
For 50 euros.
50 yens, that's fine. Matt.
And just adding onto it, this is just my question. So ID token itself actually has a facility to collect various tokens in it and with by reference.
Which one?
ID token.
Oh, ID token. Okay.
So I was wondering, what's the difference, or?
I'll have to look at the definition of ID. I don't know.
Right, okay.
Off the top of my head, at least, I don't know. Right. Thanks.
Mike Jones, what Nat is referring to is called aggregated and distributed claims,
Okay.
and it's in the OpenID Connect core.
Okay. We'll take a look at that. Okay. Any other questions, comments?
I think Aaron.
Yeah. Oh, Aaron. Sorry.
Hi, Aaron Parecki from Okta. Something caught my eye on this slide, actually, the header access token section about stir calls. When I was looking at the spec, it references something that's not called access tokens.
Yeah, they call it passport, whatever, but like it's the same concept, right?
Well, so my concern is if it is an access token, it seems not appropriate to be passing them around to unrelated parties that they're not intended for. So if it's called access token or it works like an access token, I would be concerned about that.
Mhm.
If it is something completely different that doesn't behave like an access token, then my concern doesn't apply. But the fact that it's called access token here is a little bit strange.
Okay. I get that. Okay.
Atul, are you back in the queue, or is that?
Comment on Aaron's response there. From an access point of view, I think it does make sense that an access to a particular resource is not relevant to somewhere else that you need to send it to. But from an audit point of view, would it make sense, like for an access token to be embedded into another token?
So I wasn't clear on the question. Are you asking if it is okay to embed an access token for audit trail? Is that the question?
Yeah.
Again, there are some concerns, like if the token is not targeted for a specific resource and you embed it in another token, what could be done with that token if it is just a simple bearer token? So I think that's what Aaron was referring to.
Yeah, got it. Thanks.
Yeah, I think this specific use case is really about obviously from the telephony word, but
Right.
in this case, like you call a doctor, but in the office phone, but they actually redirect it, so it still reaches the same party. It's just a different telephony endpoint. I think that's what it refers to. But so it's not just sending it to a completely different person. It's the same person, but just a different phone.
Yeah. It could be a different person, but you're right that it's the same trusted party, I guess, or the trusted domain, right? Any other comments, questions? Atul?
As we have, but I feel like then there should be some property of the token that makes it delegatable, that the person, the party that is signing it and sending it to another party has the authority to delegate that token to someone else?
Okay, Dave is next in the queue.
Hey, Dave Robin. Speaking, yes, I'm share the same concern of embedding an access token, giving it to someone else, and just alarm bells go off. So either if you're including it for auditing purposes, then perhaps consider neutering the token, removing the signature, something like that, so that it becomes invalid. It's just information. Or at least in this document, there needs to be a security consideration added about this in case somebody misses it.
Yeah.
So do not use this for access tokens in the security of this document.
Yeah, thank you. Yeah, absolutely. Okay. So that's all I have. Thank you.
Yeah, I think we, to conclude, we'll definitely have to bring this to the mailing list and answer some of the questions. Yeah, I think that's what we are going to do.
Sounds good. Thanks, Hannes. Okay. Okay. Peter.
Okay. Slide advance referred to. I just ask you to advance the slide. Is that going to work?
Yeah, I can give you control if you want, or I can.
Okay,
let me
yes,
see.
give me control if it's.
I just pass the control to you. See if it works.
Oh, okay. There it is. All right. Good morning, everybody. I'm Peter Castleman. I'm presenting the work that Daniel Fitt, Philip, and myself, and many others have been contributing to. And I wish I could have been there. This is the picture I would have taken if I could have attended today. But fortunately, we have generative AI that kindly generated the picture for me. So, okay, short agenda. Why are we here? Where are we? And then where do we go next? I'm going to scope answers or discussion about this to the topic of the cross-device flows. For the bigger discussions, catch me later. So why are we here? So this is work that started from the increased attacks that we're seeing against various techniques being developed to exfiltrate tokens specifically. And I think one of the things as we started looking at those attacks was that for the most part, all the effort tends to go into analyzing the protocol or sort of looking at those sort of technical exploits around the protocol. But one of the things that we observed was that a lot of the attacks started out at a different entry point. And they were not so much an attack on the protocol as a way to exploit it by changing the context in which users were being asked specifically to do authorization. So this is a picture that I've shown on a few occasions. And so essentially the way these attacks tend to work with cross-device flows specifically is that the attacker will find a way to initiate a session that allows them to retrieve a code, a user code, a QR code, and then they use a social engineering technique. This is not really phishing, but they're using the same techniques as phishing to get somebody to not just open an email, but to really complete the action of authorization. A simple example of it is, call it the click to win message, right? You get a message and it says, well, if you want an extra 2 months of your favorite streaming provider, follow this link, and when you follow the link, it asks you to log in and do an authorization. And of course, right, you want that extra 2 months of your streaming provider, and then after you granted authorization, you get a polite error message. and the attacker is in possession of the tokens. And there are various versions of this, work with bicycle rental schemes, but also works with productivity applications in enterprise scenarios. And one of the side effects of this is that essentially the attack bypasses various multi-factor authentication approaches, right? There isn't really a way to prevent this from happening, or the multi-factor authentication doesn't actually prevent the token from being stolen, right? So it's not really a phishing attack, which is all about getting the passwords. This is about tricking the user into saying yes so that you can harvest these tokens. I think we've talked about this in the past, right? And one of our defenses on this is we really put it all on the user, right? We say the individual has to make a decision, right? They become, and we put all the everything on them. And that's actually okay, right? For if you're sort of thinking about the end user as being the security expert, right? I call it homo securitas. They know what they're doing. They're highly attentive. Right, they actually understand how the protocol works, and so they can detect if somebody is doing something suspicious. But poor Homo sapiens, right? They're busy. They worry about breaking things. They want to help, and really thinking about ways for them to make fewer decisions, better decisions, and protecting them from bad decisions is what we need to look at. So we set in motion this sort of three-pronged approach, looking at a set of pragmatic mitigations, also looking at alternative protocols. I think there are some protocols are more susceptible, device authorization grant, more susceptible than, say, CIBA or the client-initiated back-channel authentication, and so on. And then I think the other piece is taking a look at some foundational underpinnings to see if there is more that we can do, and to understand whether the mitigations are actually effective. And so I'll talk. Well, I think Daniel, if you're in the room, we're going to talk a little bit more about that. But really, this idea of can we use formal analysis to analyze the protocols to help us understand more about where the weak spots are. And then also whether the mitigations can help. So that's why we're here. So where are we? We started back in 2021, December 2021, when we first presented the attacks. And since then, at various sessions, we have shared with this community and others, taken some input and learning, and invited the community to help us figure out good solutions. We presented a draft at a draft in London, which was then adopted in December as official working group product. So, and since then, a few more updates that I'll talk about next. So, sort of a long and winding road, but constant progress, I'm very happy to say. So yeah, we published a 01 version of the document. The main changes there, so what's new? One of the things as we started writing this down, and also as we started seeing more and more attacks, is that it was helpful to add or to introduce this idea of different patterns. So a user transfer pattern is really the one where I need to scan a QR code or copy a code from the screen to my mobile device. The client transfer pattern is where the flow gets initiated on one device, and I don't have to do anything on the back channel, right? There's some existing back channel that will trigger the authorization action on my authorization device. And then there's a hybrid pattern, which, yes, the initiation is done on the device. There's a back channel trigger, but then you, the user, still have to copy a code over, right? The SMS codes is a good example of those, right? So we sort of had to find it useful to distinguish between these patterns. So added that as descriptions in the BCP. We also had some great contributions from the community, so additional examples or added additional examples to new ones of cross-device scenarios, and also additional exploits to match those. I think I skipped over a few slides, but that's fine. The order isn't quite so critical. The other piece that we added is the mitigation limitations. I think it was pointed out that we're writing these mitigations, and even though we make the point that they're not foolproof, etc., just giving some guidance on what the limitations are. Right? When is it that they don't work? For which attacks would they not work, etc. And so we added a whole section, or for each of the mitigations, also just explaining a little bit more about those as well. Let's see. I think that is, and then of course, the other thing that we also did was for each of these patterns, each of these exploit patterns, we also added in the attacks. These were basically based on some of the attacks that we've been seeing. And then the other piece that we did was for all the examples, we mapped the examples back to one of these three patterns. So that's what's new. That's what was added to the draft. Sure, yeah. So where do we go next, right? So what are things that we're looking at next? So a few things. I was at the RATS working group earlier this week, and there's some work going on there, or some discussion about secure ranging and proximity, or an attestation for that. And this is something that is very interesting, I think, in terms of technology that can help us with answer the proximity question, right? I think one of the useful mitigations, we believe, is establishing proximity. If I know that two devices are very close to one another, there's a high probability that either it's a very, very targeted attack or exploit, or maybe that is a legitimate use case, right? These are two devices meant to communicate with one another. There's some new use cases being developed in that consortium, and so I think one of the areas that we want to look at is what is the work that's there that we can leverage and bring into the BCP, but also how can we take some of the work that's in the BCP and maybe help form some of those use cases. The other thing that folks in this room probably know about is the OpenID for verifiable presentations over BLE proposal. And so this is another cross-device flow, and I think it's only sort of an early draft still, but it's another example that we may want to reference in the BCP here, but also maybe vice versa. And I know some of the authors. I was hoping to catch you in person to talk about this, but this is sort of the other interesting thing that sort of flashed on the radar. A couple of open issues. I think some of them are more maybe a reflection on my poor command of the English language, but then I think one of the interesting ones that Daniel brought up as well is this idea of coining a phrase for the type of attack, right? So we have things like cross-site, request forgery, etc. But we don't really have a great way to describe these attacks yet, right? There isn't a nice sort of obvious one. In the document, we use this idea of illicit consent grant attacks, although that tends to describe the outcome and not so much the mechanism. And also there are other ways to do illicit consent grant attacks that isn't specific to cross-device flows, right? So it's a little bit broad, maybe. Attacker in the middle or man in the middle, person in the middle attack, again, it's both too broad, but also a little bit too narrow, because in some of these attacks, the attacker isn't necessarily always in the middle, right? They don't always have to insert themselves in the middle of the flow. And then, one of the other two of the other ones, so authorization context manipulation attack. So that one feels a little closer, right? Describes the mechanism and sort of the crux of these attacks is really what's happening. Or the other variation is calling it an exploit, because it isn't so much an attack on the protocol as it is exploiting the conditions around it. And I sort of, this is something, if folks in the room are good with naming things or are clever with naming things, love to hear about that. This is one of the things that I think we still need to sort of figure out. Daniel, or I don't want to put anybody on the spot. I know, I believe Tim is online, but if maybe the other work that's happening is around the formal analysis at the University of Stuttgart. And I don't know, Daniel, if you're in the room, if you want to speak to this, or is Daniel in the room? Yeah.
Yes, he's coming.
I am. Hello. Yeah, just really quickly, the team from the University of Stuttgart, Petra, Tim, Klaas, and Clara, are working on a formal analysis of cross-device flows, obviously with the aim of figuring out whether there are other tax variants that we've not considered yet. Also to explore what actually can help against these kinds of attacks. So are there effective mitigations? That's a question that we cannot really answer yet without this formal analysis. They already got some interesting results, very early still, but nonetheless, I'm looking forward to the results that they will have. One word also, this is analysis that is not based on the manual pen and paper model that we used for the OAuth analysis and FAPI2 analysis, but it's a more mechanized model, formal model, in the DY star model, which hopefully in the future will also make these kinds of proofs easier. But right now it's still in research, so it's take a lot of effort to build things on top of this model. But we are slowly moving towards easier applicable formal methods for these kinds of things. And Tim, I saw you online if you want to add anything.
No, I think this was a good summary. Thanks.
Thank you. Thanks, Daniel. And I want to thank the team that's working on this. We really appreciate this, and really looking forward to learning with you on this topic. And yeah, that's everything. A couple of seconds to spare. Any questions?
You're on.
Johan Schäfer. It's great to have formal analysis people from academia collaborating here, but what I would expect is to see people from the security usability field represented more. There's been a lot of research on that, and I'm sure that could contribute to this very interesting work. One smaller detail is that in addition to what looks like phishing but really isn't, there's this attack where the attacker sends multiple, maybe dozens of notifications to the user until the user is confused or just tired and will press anything. And for these attacks, it's even more difficult to assume that the user is aware of context and will do the right thing. The user will do just anything to go their own way.
Yeah, Yaron, thank you so much. Can you send me, if you have any contacts or references for the usability, the security usability researchers? I'd really appreciate that. I think we've heard that request before. If you have good contacts for us, I'd love to follow up with you on that.
I'll see what I can do. Yes.
Thank you.
Awesome. Thank you. Okay, you stay there, Peter. Go ahead. You gonna say something? Oh, are you good?
No, I'm good. Thanks, everyone.
Okay. Go ahead, Peter.
All right. So good morning, Peter. I'm going to talk a little bit about identity chaining. So Rafat and myself, but actually this, and again, Rafat, can you give me control?
Yes. Second here. You should have it coming.
I do. Brilliant. Okay, so although Rafat, my name is on there, this really is sort of representative of work by many, many people, or a discussion amongst a large group of folks from different backgrounds, different areas. And so I'm really just sort of reporting back or sharing a little bit more about the discussions around identity chaining that's going on. So the identity chaining discussions comes out of this desire to enable services within the same trust boundary and also across trust boundaries to securely and interoperably convey identity, authentication, call chain, call context information between different services, independent services. And really for the purpose of having this information is for making fine-grained authorization decisions as well as for audit purposes. The reasons for doing this is really having being able to secure authorization and identity information in microservices type architectures. So, you know, when we look at practically how at systems, there's often sort of a plethora of microservices that sits behind the front door, right? We access a service through a portal, and behind it, there's many microservices spread across multiple trust domains, multiple clouds, and really, you know, having this extra information, the identity information, is really helpful in those cases. So also to help with defending against attacks against microservices. You know, today, when we look at how you look at the zero trust policies and things like that that people try to deploy, very often it isn't very granular. And what we also tend to see is that, you know, service A is allowed to call service B, but there isn't any further information being passed around or any more granularity than that, right? And so if one of those services, if service A is compromised, it can sort of access service B at will and can impersonate or request information about users that may not have authorized it. And so we really feel like there needs to be some kind of open standard to work across these multiple cloud platforms and multiple hybrid deployments. And that's really sort of the nature of the conversation, or the motivation behind this conversation. So the kind of information that folks are looking at, first and foremost, right, how do we preserve the identity of the initiating principal? You know, I think there's also discussion around service identity of the calling service, service identities of all the participants in a call chain, the caller's authorization scope, and so on, right? Also, you know, the authorization scope for previously called services, and then also the argument context, right, with the initiating principal and also in the call chain. But the discussion, I think, has really sort of honed in on this idea of preserving the identity of the initiating principal. That seems to be the one that gets us the it's the smallest piece of that gives us the biggest gain, or at least that's kind of what's coming out of that discussion so far. In terms of prior work, right, this or background, it turns out it's not an entirely new problem, which is good news. So there has been some prior work. The edge authentication on the Netflix blog, Verizon, but also George Fletcher gave a talk on this in Identiverse, short-lived transaction tokens. Kelly Burgeon at IETF114 in Philadelphia shared the OAuth token chaining piece. A tool in London talked about fine-grained transactional authorization. And then, of course, there's the embedded token work that Rafat opened the session with. So there's also some other work in this area already. So one of the things that we've also been looking at is different use cases. So there's the API security use case. And so one example there is the one of the security camera. I buy a security camera from an IoT provider. I set it up. I have an account with them. But then there is another portal that I use to sort of bring all my different security cameras together. And when I log into that portal has to also convey the fact that it is I who signed in, and they have to convey that back to the camera manufacturer, who's going to deliver the data stream to them. And that's sort of very simple. One of the use cases for being able to preserve that identity information and do that in a trustworthy way. Preserving user context across different trust domains. So the picture that you see there, right? The user logs in, and the identity information. We really want that identity information to travel along with the call chain, so that by the time you get to the far right workload 2 on the far right top, you still know who the original initiator was, right? And then there's also similar examples around building a report in a federated environment where, in that case, you may not necessarily need to know so much who the individual was, but you do need to know that that individual was authorized, right, to request this. And again, you could be sort of 3, 4, 5 trust domains deep before that decision needs to be made. So some of the discussions that we've, or some of the options that we've talked about. So of course, the first one is just different subjects with embedded tokens. So basically this idea of wrapping a token one inside the other. I think one of the things sort of as a design concept here is that it essentially sort of becomes a form of maybe even token exchange, because you have to trust cross boundaries, right? So token exchange seems like an appropriate thing to do there. And then having that done between the authorization servers, because that's going to be more scalable as well, right? So just having trust relationships between the authorization servers rather than all the resources and all the authorization services. Another variant of this is this idea of embedded claims, or different subjects with embedded claims. And the idea here is really just rather than embed the entire token, because that may be too much information. Also, I think we heard earlier the remark that if you just take an access token and you embed it in another token, well, somebody could maybe still strip it out, and so you have to do something to make that token inert. And token bloat was the other thing that sort of was a concern. And so the other idea that we've discussed is this idea of during the token exchange, only either requesting or pre-agreeing that only a subset of the claims should be included in the token itself. So in that case, you're going to have maybe fewer. You won't have that high level of token bloat necessarily, but you do have to, on the other end, trust the authorization server to be an honest scribe. The third option is really sort of allowing different identifiers to be used in different domains. It's a little bit more involved, but it is also trying to accommodate for the fact that in these different domains, we will not necessarily have the same idea or the same identifiers across these domains, and so then there is sort of these and so we need to be able to pass information along that allows for that mapping to happen. And so in this case, there's this idea of doing that by reference and through introspection, and allowing the example.org domain query or to do introspection to determine and learn a little bit more about how to map this to the identifier in their own domain. There could be various reasons for that. One is just practically, if you have systems that have different ideas of what the user identifier is, you're going to need that. But there may also be privacy preserving benefits of such an approach. So I think that's kind of a summary of where we are in the conversation at this point. If other folks in the room have an interest in this area or in this problem, or if folks have good solutions, I'd love to hear about. We would all love to hear about that, and really happy to hear about contributions. Also, if there's any questions or thoughts or insights from practitioners who have tackled this problem, that would be wonderful to have.
Okay, thanks, Peter. Vittorio.
Hello again. You keep talking about the token exchange, so I'm going to have to keep doing the same comment. Yeah, I am glad that you are taking it so well. I think that some of the things that we are seeing here are similar to what we observed with token exchange, which is we can define things like what we want to appear on the wire, but we know that the main problem is not in the wire, is in how people decide in what circumstances those things should go into the token. And my concern is that just like we have seen on behalf of for token exchange, in which people saw the compliance with what you put in the wire as having done their homework and instead creating horrible elevations of privilege and similar to play out in here. So I don't have a solution. I am not saying let's not do this, although if I'd have authority, I would. But at the very least, let's have like red flashing warnings about this thing not being for the faint of heart, and to consider that it's not just a matter of complying with the wire. The other thing is that as practitioner, I've seen a lot of cargo cult protocol in here, in which people just look at the potential boundaries and do on behalf of across the board, and then their system just doesn't scale to what they need to do, and then they have to scrap it and just use client credentials everywhere. So I would recommend looking at various scenarios in here in which, especially for microservices, in which normally you are within a boundary in which you know about each other services, and some of the information that you're putting here on the wire is actually in environment variables, because like all those services participate in the same fabric. I would consider some of those scenarios, and at the very least mention them in the spec, so that if people are in the condition of using these, they don't bother to go 1,000 times back to the authorization server to just put a little stamp, which is needless anyway, because you already have figured this out at the fabric level. Did I speak too fast?
No, that was brilliant. Thanks, Vittorio. I really appreciate those insights. I think some of those issues around round trips and latency, etc., right, in the microservices world is, it's one of the things that I certainly see as well, right? And there's no getting away from it. And thanks for those insights. And again, I'd love to have maybe more conversation with you about this as well.
Okay, thanks, Vittorio. Any other comments, questions? Hannes.
Yeah, I just a short response to Vittorio. I personally see it more from a historical point of view, because some of these issues are not necessarily new, although the terms are new. Like if you think about microservices and then containers and so on and so on. But many of the problems have surfaced like 20 years ago already, if not longer, and people have tried to solve it back then as well. And so maybe there's actually a possibility to learn some lessons from there and adjust the terminology to today's circumstances and sort of like compute environments. So yeah, there's definitely this, as Vittorio pointed out, I would call it probably a semantical mismatch, which is of course not so easy to handle. If you take one domain and reach out to another one, there's obviously some policy or some mappings need to take place, and etc. etc. But yeah, we'll have to work through those.
Yeah, thanks, Hannes.
Okay. Any other comments? Still have a few minutes here. If not, okay. Thank you, Peter. Let's continue that discussion. Okay. Let's see. Lights, control. Okay. You're good to go?
Yep.
Right.
I get more than 5 minutes, right? There we go. Okay. All right. Hi, everybody. Aaron Parecki, presenting in conjunction with, on behalf of George and Peter, who we've at least seen Peter. I think George is online too. So this session is about native apps, and rather than coming in with a concrete proposal for a solution, I want to first talk about the problem, which is about how people are handling OAuth in native apps, native mobile apps specifically today. And this discussion is scoped to mobile operating systems. Leave the desktop world out of it for now. So this is a typical user experience that you would see in a mobile app. If anybody can actually tell me the app name, I'll give you a sticker later, but I photoshopped the name out. But this is the typical screen you see of, like, you know, log into this application. Here's a whole handful of OAuth buttons, also, you know, the username, email, fallback, whatever. If the application does follows the OAuth best practices and uses the system APIs available in mobile, you end up with clicking one of these buttons, which will then open up. Well, first you get this prompt, actually, because this is a new thing in iOS, which gives you this prompt that says you're about to do an authentication flow with this domain that you just clicked on, and you can abort there or not. And then you get the little pop-up in-app browser, which I'm very thankful that this API exists. It is the most secure way to do an OAuth flow on mobile. That browser is isolated from the application, so it can't observe any of the content of the window, so it can't observe passwords, all that stuff. Not news. This is old news. And then you log in there, and this, because it's a system browser, it shares cookies with the main browser in your OS, so you may already be logged in, you may not, you may have to type your password in. You can also, importantly, do two-factor auth, which can use things like Touch ID bound to the origin, so it's all great from a security point of view. And then eventually you get, that closes, and the app is able to finish the authorization code flow to obtain the tokens. So that is OAuth in mobile apps today. I'm sure nobody here is really surprised by that, but it is a bit of a process. And again, this is exactly what we want for third-party applications because of all the properties that we get by using this particular API that exists on iOS and Android. So no complaints there. However, when we're talking about first-party applications, where it's a service that is developing an API of some sort, they're going to make a mobile app that talks to that service. It's a first-party app, same brand, and the important thing here is the user understands that the account they're logging into is the same service as the account of the resources being accessed. So that's the first-party thing. That experience of going through that kind of OAuth flow is something that a lot of developers try to avoid when they're building mobile apps. And I get this complaint over and over and over again when I tell people, but you should be using this because it's the best, most secure solution. They're like, but we don't want our users to go through a web flow in a browser for our own applications that are branded the same as our own services. I've had this argument countless times, and I sometimes win it and oftentimes don't. And people will just do things a different way because they want to. Here's what I'm seeing of ways people have avoided following the recommendations that this group has set out in the native apps best current practice. They just don't do OAuth, so they build their own stuff, and they build in a native username and password flow into their applications, and they just pretend like OAuth doesn't exist. They will take the password grant, which was not created for this purpose, but very heavily suggested that it could be used for this purpose in the original 6749. That, of course, then leads them to a dead end if they're trying to support good MFA solutions. And then you're just in a whole world of pain at that point. Another thing that has happened is some OAuth servers, products, services end up creating their own proprietary APIs to facilitate direct interaction with native apps. So spin up a totally separate flow from an OAuth thing, and it's not called OAuth, it's just called something else, and then ship it either as an SDK or as an API to developers to use that, which is then completely outside of the scope of OAuth, other than the fact that the result is an access token that would be the same thing that they would have gotten from a web flow. This last one is my favorite because it's the absolute worst, and I have actually seen people do this where they will use the mobile apps to create a hidden web view that loads the authorization server's web page like they were doing a no-auth flow, and then sort of bridge with native code, presenting native UI elements, and then injecting that back into the web flow in the web page to pretend to the AS that they're doing the authorization code flow. And it's just like, wow, that, like, in order for someone to get to this point of going to that amount of work, you know that they like something is missing if that's what they're willing to go to. That's my point here. I could not believe that when I saw it, and thankfully I don't even remember the name of who it was, so I don't have to worry about accidentally insulting anybody by name. There are more than one, that is true. So all of these solutions of essentially avoiding OAuth and avoiding the system APIs that provide the better security experience lead to even worse things than we can imagine. So ideally, we would like to have some sort of solution that where we can bridge that. And again, focusing on first-party applications, because there is no question that for third-party scenarios, you absolutely want to force people into that web flow for all of the reasons they're laid out in all of these documents that we've already read. But for first-party applications, it is a different story. So this is the authorization code flow for web applications, and this I didn't put the time axis on the little diagram, but it goes from left to right. So starting with the OAuth client, and if you imagine this diagram in the context of web server-based applications where there is a web server somewhere else and the browser is accessing that web server, the flow essentially starts when the OAuth client tells the browser to go to the AS. So that's that redirect to AS step. The client starts the authorization code flow. The browser sends that message up to the AS. Stuff happens in the middle where the user logs in and goes through various sequences, and eventually the AS redirects back to the client with that authorization code. And the client, in the last step, goes and makes a post back to the authorization server outside of the browser, nothing to do with the browser, and gets the tokens. So what I think is actually really interesting about the design of this, which was very much intentional in OAuth, is that all of the stuff in the middle here is explicitly not written down in any OAuth specs. And that's kind of what's enabled it to grow, and we've been able to add things into products and services like multi-factor auth, or deciding how the consent gathering happens, or how many stages of that kind of thing you want to happen. All of this stuff ends up being back and forth sequences between the browser and the authorization server. So the OAuth client is kind of left out of that whole conversation. So OAuth flow starts with the client just sending one message. Stuff happens inside this black box that the client can't see. And eventually the client gets an authorization code that it can use to get tokens. This is great for web apps. So if we look at what it looks like for native apps, the line between the OAuth client and the user agent is a little bit more blurry because they're kind of in the same context in a mobile phone OS. The same thing applies obviously for the authorization code flow, where the client starts the flow by opening up this browser. The app can't see what's happening in between because it's all happening inside that browser, and eventually results in this authorization code. So if we kind of try to model what it could look like to create a way for the native app to actually be able to provide native controls to the user, you can kind of do it in parallel, or make it parallel to the authorization code flow, where if you look at this, the blue lines that are outside of the sort of magic black box here in the middle, you could define a new flow that is essentially a native apps flow that starts the flow by the app talking to the AS directly with a post request, kind of like pushed authorization requests does. And then stuff happens in the middle, which you could either put in or out of scope of this, or make two different drafts where one is the wrapper, one is the filling, and eventually result in this authorization code being delivered back, which is how the app knows that it's done. So there's a bunch of different options of how you could lay this out in one or two drafts. Again, reminder, this is only in the context of first-party apps. Just want to emphasize that over and over again in case anybody forgets that I mentioned it earlier. Absolutely only for first-party apps, not questioning that this should be used for third-party. But that would allow some sort of solution to this, would allow developers to be able to actually provide a flow that works with native app controls that they are then not going to find clever workarounds to just doing it that way anyway. So this is, these are a couple of the questions to answer around this discussion. I think the OAuth working group is the right place for this work, because ultimately we are talking about access tokens and refresh tokens being issued in response to whatever this flow is. It will likely also result in ID tokens being issued, but I think doing that work in the OpenID Connect group is the wrong layer for that to happen, because it would be, we are going to end up with access tokens at the end. The big question here is the second one, that black box in the middle. Should this kind of native apps flow just describe the beginning and the end the way that the authorization code flow works in OAuth, where it only describes the beginning and the end, and everything in the middle is left out of scope and then has to be built by product people? Or could this spec actually define some amount of the back and forth that happens, whether it's actually whether it's the details of gathering consent, gathering passwords and multi-factor challenges, or just a generic challenge response format that could be used to insert the specifics by providers once they're actually building it. So these are the kind of building blocks that I see we need to decide the scope of this. But I wanted to start the conversation here because I do think this is actually a very real problem of essentially people trying to avoid using OAuth or using OAuth in horrible ways where it's not really anything that any of us would consider OAuth anymore when they are building native apps, mobile apps for first-party clients. And I think that's my last slide.
Rohan.
Hi, I'm Rowan May. I work for Wire. We have native apps, and I'm just going to give you, so I don't really have much of an opinion about where this work gets done, but I think that doing this work and standardizing those details in the black box are essential. Let me give you a user interface example for why this is such a pain for us. So I have a messaging app that can support multiple accounts. One of my accounts is, let's say, an enterprise account that's using OAuth, and they have multi-factor. So on that account, I have to re-log in, and I start my authentication process. I pop up a browser, which consumes the whole screen. And while I'm in the middle of entering that, I get a call on another account. That user interface totally sucks, and we need to be able to control that. So I would like that to be worked on. Thank you very much.
Thanks, Ron. Joseph.
Joseph Heenan, Orthleet. Yeah, I mean, I think we've talked about this before. This is very much a real problem that we see a lot. I mean, some of it sucks, and there's solutions that should have been done ages ago, but they're dependent on the OS vendors. Like, there's absolutely no reason you should have that interstitial. Do you want to sign in with Google when you're coming from a Google account? And there's existing mechanisms that could have avoided that, like the same mechanism used for claiming HTTPS URLs. Why they've not done that is beyond me. I think we probably do need a more accurate definition of exactly what a first-party app is to see if we're including Rohan's use case or not there. And I think there may be some overlap between the possible APIs you're suggesting in the second bullet here and what apps are already doing for app-to-app, where the mobile app needs to be able to issue an authorization code to a different mobile app on the same device. I think it was already probably a good idea to try and look at standardizing that part of the flow, and we could possibly kill two birds with one and a bit stones here, and I'd be happy to collaborate on some of this.
Thanks, Joseph. Vittorio.
Hi. The black hole thingy can be done today already. Let's say that when you redirect it to a protocol schema, which is an app instead of a browser, and the app can show whatever UI it wants. So we already have these today, and the fact that no one does it somehow makes me think a bit. I think that the idea is sound, and it's true that customers ask for it, but you leave the biggest part undefined, which is if we were to decide to interact with a authorization server not using the browser, now we have the entirety of all the things that the authorization server needs to be able to do and present to the user undefined. And in the industry, we have things that you can use, like, for example, XAML on the Microsoft side is a layouting language that you can use to describe a native UI that you could put in there, but it's very proprietary. It doesn't know what's going on in there. Distracting you. And it worked. So I think that before moving to whether it works or not, I would personally love to see some proposals in there, because I think the devil is going to be in the details, both in terms of expressive power and also in terms of competency. Let's say that some of those things might go down to the mechanics of authentication, in which case places like FIDO seem to be a better home for it. Because again, I understand that what we spit out are access token and ID tokens, but that doesn't automatically make us competent for the stuff in the middle. As in, we didn't design any of the HTML that the authorization servers are using for driving those experiences. So I think it's a bit of a straw man to say that this is the right place without more details.
So I will note that we do have a couple of starts to drafts around this space that I just didn't want to burden this discussion with, and they do span the one is essentially the start and end. Like you just define the beginning and the end of the flow, just like the authorization code flow does. And the other one does get into the middle here, and it doesn't define any UI, but it does define the wire protocol in which you could send passwords, MFA challenges, SMS codes, and ideally, hopefully, WebAuthn challenges as well. So there is, and some of those are actually based on implementations as well. of these proprietary implementations. So just to, but yes, I have not seen any details of the UI being specified in these, which is a interesting problem as well.
And also, you already know my comments on those specific.
Yes.
Justin.
Justin Richer. So I think Vittorio's point here needs to be very soberly considered, because anytime I've seen a system that starts with, oh, we're just going to send a password and this other stuff over the wire, ends up reinventing HTML. This was actually the topic of my undergraduate thesis project back 23 years ago, somewhere around there. It was a long damn time ago now. And I think it's still true. Yeah, it is absolutely still true. And it's just, I would be very worried about the creep of an effort like this. I do think that there is absolutely merit in defining this type of, back and forth direct protocol type of thing. I think that there's a lot of value in that. It's just, it worries me that I think that inevitably and probably not too far into the process, somebody's going to say, instead of sending, give me a password, I'm going to send you, fill in this input box that's 30 characters long and 10 pixels high, and it happens to be a password. We've already seen proposals like that sent to the OAuth working group. Travis and his group at Curity sent a thing, it was a year or two ago, something like that. Wasn't the first time, won't be the last time. And if this comes into the group, that's definitely going to be a big topic.
Yeah, I agree. There's a fine line to draw here, for sure.
Okay, Rohan. Let's wrap it up.
Hi, Rowan again. To Justin's point, I mean, I think that what we want is you didn't have to. What we used HTML for was we just sent some forms and you filled things out, and but we didn't define any of the semantics of the data, right? And so if to do this, to have this be something meaningful, you want to have something that is semantically meaningful and not just here's a field that, as you described, right?
Go ahead. Yeah.
Justin Richer, that is the reality of HTML. The actual definition of HTML is that it's a semantic document description language. So we need to not reinvent HTML. We probably don't want to adopt HTML. I don't know where the right answer is. Mike said it's the semantic web. I will throw you under that bus so fast. Go for it, man. Yeah. Okay, so yeah, this is all going to be Tim Berners' notation 3, and it'll be we'll be fine.
Okay.
Yeah.
I think that was a great way to end that discussion.
Yeah. Let's do that. Awesome. Thank you, guys. Okay.
Thanks for this positive outlook with the throwing under the bus.
Okay.
And I think, Mike, you are going to start this one.
Okay.
Let me pass the thing to you.
So I'm Mike Jones. Aaron and I had two different drafts with some overlapping functionality. And he reached out to me last week saying, well, do you want to combine the discussion so that we can confuse people less? And I said, that's a good idea. So we had a call and worked on a deck before he went out as a tourist a day or two ago with some of the rest of you. And here we are in Yokohama. So there's two drafts. The thing in common is both enable a resource server, a protected resource, to identify one or more authorization servers that a client can use with it. It's a straightforward thing to want to do. There's different ways you can do it. I was the author with Phil Hunt of a pretty old draft, which I'll go into the history of on the next slide, that defined a .well-known location for OAuth protected resources to publish metadata. This is very analogous to RFC 8414, the authorization server metadata that's in widespread use. That's been a success. The first draft was actually developed at the same time, but I won't do the history now. In the metadata, you can publish other things like keys and documentation and terms of service, and the same kinds of things you can publish in the authorization server metadata. Whereas Aaron's draft, which was also talked about in London, or the idea for it was talked about in London, can provide an authorization server issuer in a www authenticate response in response to a request to the resource that, for instance, doesn't have an access token. www authenticate is used in a number of ways in our specs to give at runtime the client information on, if you do this, it'll probably work better. So I'll talk about the first, Aaron will talk about the second, and then we'll have a free-for-all. So the protected resource metadata draft. To be really concrete, this is what a request for that metadata would look like at a resource called resource.example.com. You would use the proposed well-known location OAuth protected resource, and you would get a response. The response is on the next slide. So again, this should look really familiar, except it's protected resource data rather than authorization server data. The first element, the resource one, is so that you know that you're not being spoofed. The authorization servers list is the thing that's in common, which prompted Aaron to say, hey, we should get together. You can have multiple, you could have one, you could have none. There's something to declare some things about what kind of methods you support. That could be extended. The whole point of this, like the authorization server metadata, is that it does define a registry. It populates the registry with some stuff, but it's extensible. And so just like the AS registry has been successful, I would imagine this would be likewise successful. Next.
Do you want to take comments about this? John, what was, do you have a comment?
Let me give the history and then
Okay. You want to go back?
Go to the queue.
Okay.
So we created the protected resource metadata draft in parallel with the AS metadata draft. I read the minutes from the meeting in Seoul, Korea, and tried to figure out, okay, why didn't we adopt that at the time? And people like Tony Nadalin and John Bradley at the time said, you know, one's in use, one is not. So let's adopt the one and think about the other. And the thinking has taken a number of years. It turns out that in the OpenID Federation space, there were concrete reasons to want to have such metadata claims about a resource server. And so the OpenID Federation spec now uses some of those metadata claims. This is actually in production use in the Italian Federation deployments. In fact, its use is required by the beautiful spec below, which is in English. There's an Italian version, of course. This week, I actually got feedback from IANA that the change controller for the registry, we used to say IESG, they said, please change it to IETF. So I did that, so the draft is no longer expired. There we are, it's now actually in use, unlike 2016. Go to the queue.
John.
John Bradley. So way back when we first did OAuth, this idea was also contemplated. And in fact, we added the response header saying what scopes are required for the resource. Yeah. But we had a significant security concern around saying what the authorization server was, because it is a wonderful, wonderful phishing opportunity where if a client goes to a resource and attempts to access something and the user winds up going to something that looks like Microsoft and is asked for their credentials to log in, you know, we've now created a new way for phishing attacks. Not that there aren't lots of other ways. So I think this, as it always has been, would be a really useful thing to have, but we really do need, if we're going to go forward with this, we need to put in a lot of thought about what, so in a federation where you know that, yes, that resource server is trusted, that's one thing, but random resource servers sending you to websites could potentially give us a black eye. So we need to put a lot of security thought into
John,
that.
I'm going to corner you if this goes forwards, and we're going to write security considerations.
Well, the answer is clearly unfishable credentials, of which I have some I could give you at a discount. But you know, given that we're not in that world yet, we need to consider what the security implications of this are. There are unintended consequences to this goodness.
Thank you.
Thanks, John. Nat.
Nat Sakimura, Nat Consulting. Some of you may probably remember something called OAuth meta draft that was created back in 2012. It's giving when you access the resource server, it gives out the list of authorization servers that it may want to accept from. So, but that draft actually didn't fly. It was actually in development until 2017, and the OAuth working group actually didn't like it. I guess some aspect of that was using GNAP. I don't know, maybe. Well, in the initial presentation, you were talking about that. So, but anyways, one of the pushback for that is, I guess, exactly what John has spoken out. But then now that we have accessible, usable, phishing resistant credentials, maybe it's time to reconsider. So that's my point.
Thanks, Nat. Joseph.
Yeah, so I think just to say, I agree with what John said. I think it probably goes beyond needing security considerations. I think we need to think hard so that if a resource server sends the user to an authorization server that is completely unaware of this spec, that somehow the process just breaks. I think that's the kind of thing we need. It's not just, hey, there might be some sharp edges here. I think we need to get rid of the sharp edge.
Well, in some sense, right now, you're already pre-broken if you don't have an out-of-band way to know that information. These two drafts are proposing online ways of determining that information so that you can establish the connection without doing something out of band. Now, I understand out of band has different security characteristics than online, but anyway, we'll save more discussion for later.
Justin.
Justin Richer. This is a great idea that has lots of sharp edges and several foot guns. And it's the kind of thing that like this has been deployed in UMA-based systems for ages.
Okay.
And you know, any type of like federated AS discovery type of thing that's built into that protocol. You know, GNAP does have a feature that allows this type of discovery from the RS if you want. All of that said, though, yeah, there are some pretty big security considerations, not the least of which on the OAuth side, we've had several well-documented attacks against sending somebody to a malicious discovery document that crosses the authorization endpoint and the token endpoint from different places because of different OAuth flows
Yeah,
and
the
things like
mix-up
that.
attack, etc.
Exactly. Then there's what I tried to get Nat to call the random AS attack. I just really want something named the random AS attack. That's all I want. Anyway, the other big aspect that people haven't brought up though is there's a huge privacy consideration here in that if I go to a protected resource and I ask it like, hey, how do I get access to this? And it tells me go to this authorization server, but I'm not going to tell you what is at this resource. Well, if that authorization server is like accounts.google.com, I didn't learn a whole lot. But if it's Aaron Parecki's iPhone, then I just learned a bunch about what's behind that resource that I didn't know before without getting access to the resource, right? And like we are going towards a space where people are building more and more distributed systems, more tightly coupled systems. In the coupling is tight between an individual resource and an individual authorization server, various gateways and stuff to actually make them all connect together. Like there's a lot of sharp edges here. And the thing about this type of discovery, though, is that I can deploy this at a resource server without telling the authorization server that I did so, and this works, right? So we can't break it. I would be very interested to hear what that is, because the way that I see this model, we cannot break it because all you're doing is saying, go do OAuth over there. Right? And sometimes you learn a lot more, an attacker can learn a lot more than we want them to by just saying, go do OAuth over there in an automated fashion. And that itself could be dangerous, in addition to the types of attacks that John was talking about. All that said, I don't think this is a bad idea. I just think it is a potentially dangerous tool. We still have chainsaws because sometimes we need to cut down big trees. But, you know, you shouldn't use it to butter your toast. And people, you need to be very careful with how you present these types of things.
Thanks, Justin.
I want to hear Aaron's draft.
Yeah, we've got a lot more. I got a lot more stuff so can we save some of the questions because maybe some of this will be relevant. And I don't want to end up with 2 minutes left. Okay, what I wanted to do was talk about some of the other. I've got it. I want to talk about the other approach to this that is that triggered my wanting to combine the sessions. But I also want to talk about some of the concrete like motivations for this. And I totally agree that there's a lot of ways in which this is not a good idea, but there are some cases where this would be helpful or even necessary. One example is that kind of actually spurred this whole thing is the calendar and email app discussion. And this was from London. This is why Ben's name is on the slide as well. He presented to this group a possible solution to the use case of wanting to bootstrap a calendar app. And then I worked with him over the last couple of months to make it fit better within the mold of the OAuth group. And then we ended up going the authorization header route, but then I noticed that Mike had done a resource server metadata draft, which would kind of solve the same problem. But the point here is that in this world of calendar and email apps, it's the most concrete one I can think of that is very widely deployed, and everybody here probably uses them. There are dozens more situations that are similar to this. But the point here is that these applications are generic applications meant to work with arbitrary resource servers because there is by definition no prior relationship. You download a calendar app from the App Store or just onto your computer. it obviously does not know about every calendar resource in the world. That would not be possible. And it cannot have a prior relationship. Same situation with WordPress, right? You can download WordPress you can install WordPress on a server. If you download the WordPress mobile app, obviously that mobile app cannot know about every WordPress install in the world. So there's, by definition, no prior relationship. So in that specific case, the user is the one establishing the relationship between the client and the resource server. And that's the definition of the problem. And again, I want to make sure it's very clear. I'm not suggesting that every resource server needs to use this draft. That would not be a good idea. There are many reasons why you would want the out-of-band configuration, out-of-band configuration linking the resource server and authorization server. But in this case, there is, by definition, no prior relationship, and the user is the one that brings the relationship. So that's the scope of this problem. In the calendar example, this would be what the request would look like. Basically, the client could do this. Well, actually, I'm missing a slide here. Now that I think about it, there's the slide that's missing is the what it looks like when a user sets up a calendar app. And today, what that looks like is there's a field for the server and there's a field for username and password. And that is what happens today. And that is not great, right? For many reasons. So that is where we are today. So instead, that could change to provide just the server name. The calendar app does this request to discover the authorization server and then does an OAuth flow. And in this case, I would say the web-based authorization code flow, not any kind of native weird thing, because this is a arbitrary application working with arbitrary authorization servers. And it would do this discovery, get the AS metadata, figure out where to send the user to, find the token endpoint, all that stuff. That's 8414. This is the regular RFC 6749. This means you can enable multi-factor auth and non-phishable credentials on your calendar app setup, which is today not possible. And then eventually the flow is done, the app has tokens, and nowhere in this process was the user's password or any credentials shared with the native calendar app. Then, of course, the app can now use the token to fetch the calendar data. So this is, I really just wanted to add in that context of like the scope of the problem. It's very explicitly when the user is the one creating the relationship between the native app and the authorization server. So let's see if I remember some of the comments that I wanted to respond to. I should have just jumped in. I think the world, so not adopting this resource server metadata draft in the past because of the phishing concerns, I think was probably the right decision at the time. I do think that the non-phishable credentials is now hitting the point where it's going to be widespread very quickly and not really a concern anymore. So I think that the credential phishing concern is going way down as far as it relates to this draft. Also, it is, again, the definition is it's a user establishing their relationship with that app. And if you're worried about phishing, there's nothing stopping the user from just putting the password into the native app right now and putting in the wrong resource server and getting tricked into setting it up that way, which just ships the password out anyway. So it's not really that much worse to do it via an OAuth flow. I do think that it's a good idea to try to stop as many of these problems as possible, especially the trying to trigger this with an AS that doesn't know about it. So maybe there's a way we can sort of create the bidirectional link of an AS having to acknowledge that it does support this resource server in some way. The resource indicator spec comes to mind. If this spec actually says when the client starts a flow, it has to include the resource indicator as part of the flow, then the AS could reject if it doesn't know about that resource. I think there's ways we can create that bidirectional link to solve that particular problem. But yeah, what's on the next slide? Oh, this is the last slide, right? Okay. I think there's an interesting overlap between the two different approaches that have address this problem. I don't have any particular attachment to either one of them. I don't care about whether we end up using an HTTP or a www authenticate header or just go with the resource server metadata. There is interesting differences in them, implications in the differences, and also potentially interesting to actually use both together of possibly, but all of that is like, I think, details that we can talk about later on the list or now, but I think what's more interesting to me is just the scope of the problem. So, okay.
Thank you for explaining that.
Yeah, great. So, okay, now we have a few more minutes for questions.
Justin.
Justin Richard, just to expand the scope of this a little bit. But no, I think user-driven security decisions is an important aspect of this, and I think that that's far and away going to be the driving concern. But there are also other contexts, like so I think it was John mentioned that within a federation you might have, know the identity of a resource server and know that when you're given an identity of the authorization server, it's on your allow list of things that that you're to talk to and stuff like that. All of these are tools to help the application decide whether or not this is something that they want to do. Where we run the risk is this really is this user-driven cold boot model, because that's where the real attacks happen. All of that said, I absolutely love that space. That's why I threw my hat in for the dynamic registration spec with all of the problems that dynamic registration has in practice, right? Like, because you're showing up and nobody's ever heard of you. How do you even trust that? And how do you deploy that in a trustful way? There are ways to bolster this. There are ways to actually make people, or at least encourage people, to think about this in a practical and reasonable way that can actually help. It still is very sharp. But sometimes, like I said, you need sharp tools, and I do think that this is a good one, and I would actually be in favor of combining both approaches, specifically because there are lots of use cases that I can think of, strawman use cases just standing here right now, where one or the other just flat out does not fit, does not work. Mm-hmm. And so to me, that's an indication that we do need different ways to approach this.
Christina.
So there's potentially a third way to do this, which we've already built into the OpenID for verifiable credentials issuance specification, which is based on OS. And the stories there is, to your point of user initiated. Well, let me first give. So what's happening in that draft is authorization server authenticates the user, and the data how about the user gets issued from this new protected resource called credential endpoint, and it can be any format, right? And the thinking there was a bit different from here potentially. There originally we put this new credential endpoint metadata in the authorization server metadata file. So things like credential format supported, algorithm supported, whatnot. And then as the implementation started, the feedback started coming in. People wanted to reuse existing authorization server metadata files because they're reusing existing authorization servers. And that's where it was an implementation challenge to add this additional chunk of metadata in there because of lifecycle management and all that. So the request to separate the two has been increasingly becoming louder and louder. And we had really long conversation on this topic because potentially part of some of the concerns we've already heard. And the approach now is somehow there's one mechanism defined in the spec. The issuer, the resource server, communicates this resource endpoint, not endpoint, the issuer identifier to the user, or somehow the client already knows it, and it appends not well known / OpenID credential issuer path and obtains a resource server file from there. And the only part there is relevant to here is there will be authorization endpoint string, not an array, a string, where you append .well-known / and or you do usual and then how you get the authorization server metadata. So I think I don't know if we need to define the paths for general resource server like in Mike's draft. I don't know if we need to define concrete metadata like in Mike's draft, because that would be pretty resource server specific. And I'm really against having an array of authorization servers like I saw in Mike's draft, because that is a serious security concern. It has been, at least in the credential issuance resource server space, having two different authorization servers potentially for the same issuance endpoint has been a big security concern. But the idea of how can I, given I know the resource server's identifier, how can I obtain the credential authorization service metadata from there, like that problem statement, I see the usefulness. And I don't know if we need a generic draft for that, or it could be, like part of these OAuth extensions like VCI spec, or we need a general draft, like I don't know yet. But so +1 to certain aspects of the presentation I've heard, big -1s to the rest.
Thanks, Christina. Joseph?
Joseph Heenan, Authly. Just to respond to a couple of things. I mean, I think your point about it being a user-driven process is great, but I do worry that it's putting a level of trust in the user that history has shown we should not put in the user. I think having the resource indicator draft as part of the solution is definitely great, but I think the worry there is that it's not going to make the flow break on things that don't know about the resource indicator draft. And although I'm going to say something that should probably be taken out the back and shot, there are ways we can break the flow, like defining a new response type that means it wouldn't work with a server that didn't know this draft. Probably not the way to go, but there are definitely some possibilities, I think.
Thanks, Joseph.
So, Joseph, to your point about breaking things by using the resource indicator, 6749, as you well know, says you should ignore stuff you don't understand. And in fact, you have personally written test code to verify that at least Connect implementations do that. So, well, yeah, people can write bad code, and they do. This is the extensibility point we have, and we've used it.
Yeah, I mean, that is definitely the issue, is that unknown stuff should be ignored, but that doesn't expand to things like, that doesn't cover things like response types. I think you have to fail if you get a response type you don't understand. So
I do just want to, again, on the point of not making the user the one that's responsible, that's not what's happening here, because this covers the cases where the user is already responsible for that. So the user does already copy a string from one place to another to configure a mail client. So like, we're starting with that assumption. We're not trying to say, oh no, the user has to be really sure about checking the consent screen to make sure that a link they clicked on is the right app. So that's there. I think they're very, very different considerations.
I do agree with that point. I think in a lot of places we go to great lengths to try and avoid the user having to do those types of copy and paste. And I think it would be better to start from the point of view that we should try and avoid it if we can. I mean, if it turns out to be impossible, fair enough. But I think there's, this could be a very popular mechanism.
I agree that we should try to not create new scenarios where that is a problem. But I mean, like the problem scope is, we're in that world already. Like bootstrapping an app that the user decided to use. They're already doing that work.
We're running out of time, so I want to allow Tobias to get in here. Go ahead.
Yeah, I just wanted to comment that with these two approaches, the one that would perhaps be more consistent with other expectations around OAuth is probably the well-known setup, primarily because If I get a just-in-time response, how do you know to go to an authorization server? What if I'm not a registered client, right? I've gone and made that request, and I simply can't obtain an access token because I'm not registered or identified as a client with the AS that it's expecting me to go to. And I know there's dynamic client registration. I just wanted to kind of relate that to the conversation we were having earlier this week as well, around exploring other techniques. We can have a client with self-describing identifiers like URLs that might support a more just-in-time setup and just kind of link the left to the right. But personally, I see use in both mechanisms as well in a single draft. One question I had, which I assume is probably an obvious answer, is the use of the authenticate header in the response could be overloaded for multiple AS scenarios. Or how would you handle if I'm a resource server and there was multiple possible authorization servers that the resource server could trust?
Yeah, there's no, in the current version, there's no support for like multiple issuers, but I mean, these are the details that like.
Yeah, right, okay. But there are solutions to that.
We'll figure it out. Okay. Oh, and then I just wanted to hint that the other overlap here is with the step-up auth draft that's the other one that uses authenticate to tell the client what to do. So there's I feel like there's a little bit of cross-linking that needs to happen between the two drafts if this keeps going. Uh-oh, did I invoke the...
We're running out of time. So if you have a quick comment, Vittorio, go ahead.
Super quick. On the step up, we explicitly rejected this functionality because we were worried about all the things that were mentioned here.
Answer them.
You rejected what specific?
Sorry, we rejected the use of of our spec for discovery of the authorization server, precisely because we were very concerned that people would have a chance to just inject, go here and I'll steal your stuff.
I agree.
So as for the overlap, we should talk.
I agree that it makes sense to restrict that for the step up draft 100%. Yes.
Thank you.
Thank you, Vittorio. Last minute comment, anything to wrap up quickly?
Should we try to produce a combined draft and
It looks like
go
it
to
there.
the list with it?
It seems like there is good support for that, so go ahead and do that.
John, I'm going to tackle you on security considerations and sí, señor.
Thank you, Mike and Aaron. Sri. Do you want me to drive from it? Okay. I'll drive slides. Let me know when you want to move the slide, okay?
Yeah. Hello. My name is Sri. I'm from Lulu University of Technology, and I'm here to present a power of attorney based authorization technique with OAuth. So power of attorney based authorization technique, you might be familiar with it. It's a traditional authorization technique that you can traditionally people used to transfer their asset to someone they trust. So we were thinking to take this idea into this digital age where we can transfer your power to your trusted device or a client, so that this device or client can work on behalf of you, even if you are not available at that moment. Next slide, please. Yeah, so what does it add to OAuth? So it actually adds a new role, which is the principal just before the client. So it's actually controls the client or owns the client. And this client is the part of the OAuth. And also this principal, this new role there is a possible separation between this principal entity and the resource owner on the other side. So this enables the client to access the resources owned by the resource owner on behalf of this principal, which is different from the resource owner. And of course, there is a time limitation, and even if the principal is not online. And also we introduced the multi-level delegation. For example, you have the client, say client 0, and we have client 1, 2, 3, up to n. So you can transfer so you get the POA or power of attorney from the principal, and the principal send it to the client, client 0. then the client 0 can send or transfer the POA to the next client, and it goes like that. So it is also possible to do this chain or multiple level of delegation. Next slide, please. Yeah, the motivation for this is basically to introduce introduction of this new entity, which can be useful when the user need to access the resources owned by another entity, like a resource owner. So yeah, that was the main motivation, and also it will be helpful for to work to make the devices that you trust to work on behalf of you. Yeah, it is mainly helpful in some scenarios like subcontractor, contractor device, industrial cases. Next slide, please. Yeah, this is the protocol flow for the our idea. So especially when you look into step A, B, and H is the new lines. So A is the transferring of POA from the principal to the client. So the principal is the one who generates the POA, who signs it, and the POA is of course in the format of JWT right now, and it sends it to the resource owner along with some authentication, and then and then the C, D, E, and are already part of the auth. We are using the authorization server there in E, step E, and then H is an optional step. Where the client can actually send a report or an acknowledgement back to the principal that, okay, I have done this task that you have assigned to me. Yeah. So can you go to the next slide? Yeah. Yeah, this is the format. So currently we have done it in JWT, but we are also thinking about CBOR if you are looking for some IoT devices like constrained. So when you look at the payload, like we have this metadata where the principal can add all these relevant credentials as part for the authorization, and also the transferable parameter is the one that I told about. I was talking about multi-level authorization. That is the parameter responsible for that. So if it is an integer like 0, 1, 2, 3, so it depends on the application how many levels of delegation you need right now, and also the credentials parameter where you assign this specific particular task to the client. Yep. Next slide, please. Yeah, so we can use it for IoT devices, cyber-physical systems. So we have a draft in the IoT ops that we have presented last time in London. Yeah, you can check this link for that, for the draft. Next slide. Yeah, one of the motivation for this draft was there was a discussion last year how to integrate or how do we collaborate with OAuth, and it was very similar when we explained what is POA in the IoT ops. So yeah, so we have another draft for positioning of POA. So that's explaining the difference between other existing approaches like UMA, GNAP, and what's the main difference between this draft and the existing solutions. So yeah, appreciate reviews and comments from the working group. Yeah, that's the last slide, I think.
Okay, yeah. Anybody has any comments, questions, thoughts? Has anybody had a chance to review those drafts? Anybody? No.
I see.
Nat.
Nat Sakimura, I'm so sorry I haven't read your draft, so this is just a question. The oath is actually taking care of a very special case where the client user and the resource owner is one and the same. It's a three-cornered model, and it's a little bit specialized case. The general case being client user and resource owner is different, the four-cornered model. And for that, at OpenID Foundation, we have something called SIBA. So the user of the client and the resource owner is actually different. Resource owner is going to give the authorization And with that authorization, the user of the client is authorized to do a scoped stuff. And while I was listening to your presentation, I kind of felt I might be totally wrong, I kind of felt the overlap there. So if you could elaborate on, in this kind of framework, it's much appreciated. Thank you.
Yeah.
Are you familiar with the CBA specification?
No, I will look into that. Yep.
Okay. Okay. Anybody else has any comments, questions? Did you send an email to the list with those specifications?
I forgot to put the positioning of POA, but yeah, the draft, yes. I didn't send, I don't understand. Like.
So, like, we have an OAuth mailing list.
Mhm.
Did you send that to the list so to ask people to review the document?
No.
Okay, so maybe
Uh-huh.
this is the next step to do that, so people can review the document, so
Okay.
they have some opinion about this because they didn't have a chance to read it.
I see.
Another one is, as Nat suggested, maybe take a look at the CBA specification and see if there is some overlap there and what
Sure.
that could be done. And I see Olof in the queue there. Olof, do you want to say something? We can't hear you if you are speaking. Okay. I guess that's it.
Yep.
Okay.
Thank you.
Thank you.
Thank you.
I think we're done. Any other business? We have a few more minutes extra here. Any other business?
Well, Rifat, maybe we should sort of speak briefly again about the idea of doing some intro meetings following this IETF meeting, just to deal with some of the topics that we weren't able to cover in site meetings. For example, there was the mailing list discussion, and we said that we would try to identify or condense the topic a little bit in one of the site meetings regarding state, the whole state topic, science state, etc. That would potentially be a topic we could cover in a intro meeting. There are lots of others, of course, based on the work items.
Yeah, like obviously we've done interim meetings in the past, and we've done a number of those, even weekly interim meetings, that we would happy to do those. If you guys have any topics, let us know, and we'll try to facilitate that, right?
Rifat, can I try now?
Yes.
Yeah, hi,
Yes.
sorry, I had a problem with the microphone. Now I just wanted to follow up. So this draft where we positioned the POA, we have collected all the comments from the London meeting on various other protocols where there could be an overlap. So we will add the CBA to this one so that we have, and then we keep this OAuth draft clean, just as a proposal for how we want to do it. And I also wanted to add, when we do multi-level delegation here, of course, then we put POA inside POA. So it's signed in several steps, and you can see each step of POA, so you can trace back completely. If you want to have that, you can set it to 0 also to not allow multi-level delegation.
Okay. Awesome.
Thanks.
Thanks, Olaf. Aaron.
Aaron Parecki. I just wanted to say I really thought that when we were doing the weekly interim meeting series, I thought it was very productive, and I think I'd like to see if we can do something like that again, where it's more than just the 3 times a year synchronous sessions.
Yep.
So just wanted to say I very much support that.
Sounds good. No, just let us know what topics you want to discuss. So send us those topics, and we will facilitate that for sure. Okay. Thank you all, and have a safe trip back home, and enjoy the rest of your week. See you in San Francisco, hopefully.
Yeah, thank you all.
Good to see you. Good to see you as well.
I really need to run.
Okay.
See you. Yeah, of course.
Have fun.
Oh, yeah, I will.
Are you going to the train station or?
Yeah, I have a meeting with the mayor of Tokyo.
Oh, wow. I'm going to Haneda after I say my goodbyes to people.
Oh, you're going to have after this? Okay.